Hey, this is a do now question. Hit pause while you finish this problem up, and I'll just wait here. X. Okay, so solve for X. We're gonna take 2 steps to do this. We're gonna cancel that one by add 1 to both sides, and then we get 2x equals 8. Divide both sides by 2. X equals 4. Swell, that is amazing work. Nice job. Today, we're looking at solving literal equations. Our learning targets will be able to solve literal equations. That's great. We've been solving equations for a long time now. But what's a literal equation? Good question. The easiest explanation I could tell you is that a literal equation is a formula, but that might not quite capture everything. So a literal equation is an equation that has many variables. It might be that it has only variables, no letters at all, just plus, minus, times, divide, and a whole bunch of letters with an equal sign in there. But there could be letters and numbers mixed together, right? But an equation with many variables can have more than one variable. Okay, so here's what you need to know about solving literal equations. There's 2 things. One, the process of solving equations never changes. So whether you've got an equation that has just a single x, and then you take your steps to isolate the x, or whether there's multiple variables in there, the process is exactly the same. You're going to do the opposite operations to cancel stuff out and leave behind just the thing you're trying to solve for, right? And the second thing you're going to mention is that since there are multiple variables, we really have to pay attention to the directions, because an equation such as this one, 2x plus h equals p, which is actually the do now question, but I changed a couple of numbers into letters. There's 3 possibilities of what the directions could ask, right? It could say solve for x, it could say solve for h, it could say solve for p. And then the do now, it was pretty much obvious. It's like, well, I can just solve for x, is what we're doing. But when you've got a whole bunch of variables, you have to pay attention to what you're supposed to solve for. Otherwise, you end up doing the exact wrong thing, and you do all this work, and you're like, I got the answer, and then you're like, why is it wrong? Oh my gosh, I solved for the wrong equation. So pay attention to the directions. Okay, so this time we're going to solve for h. So I've highlighted the h in the directions and in the equation both. We're going to leave the h alone and get rid of the other stuff on the left side of the equal sign so that I can get the h by itself. Pardon my bad handwriting. That's an x. So the positive 2x and negative 2x, those are opposites that cancel. And then this h is going to come straight down, the equal sign. The p and the minus 2x's, those are not the same letter, right? They represent different variables. They are different quantities. They represent different numbers. You can't combine them. They are not like terms. So we just leave the p there and then put minus 2x afterwards, right? If you remember the different examples I've used before of like terms, this could be like packs of gum, but the P is a different kind of pack of gum than what the X represents. So if you got, Bubblicious, that's got only like 6 sticks in there or 6 pieces in there, and then you got like Trident that's got like an 18 pack. Those are not the same thing. You can't count them the same. So P's and X's are different. Don't combine them. Okay, next example. Next example. I'm going to do this one twice. So we're going to solve for C. I do it the kind of the more straightforward, with the more obvious approach, and then I'm going to do it a faster way. But we're going to start with the more obvious way. So there's the C. I highlighted in the directions and in the equation. So I'm going to leave the C alone. I'm going to subtract this Z from both sides. So the minus sign is attached to the C. Whatever sign is directly to the left of the variable stays with it. So negative C plus 2, whoops, oh my gosh, plus 2. And then a V and a Z, those are different letters, so don't combine them. We just put V minus Z. Subtract the 2. These cancel. So I still have a negative C. A lot of times people will just, not on purpose, but they'll forget about that negative sign. It just gets left out, and then you finish, and you're like, why is that wrong? Well, I accidentally forgot part of the problem. Okay, so negative C equals V minus Z minus 2. So that has an invisible 1. on the c. Negative c is the same as negative 1c. If there's no coefficient given, it means 1. And I think that's helpful because then we can see it and we know, all right, I need to cancel the negative 1. It is not a subtraction. The operation at work here is multiplication. That negative 1 is multiplied onto the c. I'll put a little dot right there. So to do the opposite would mean divide. So I'm going to divide by negative 1. I'm going to divide the other side by negative 1 also. Those are going to cancel. So I'm going to end up with a tiny bit more space down here. C equals, and then when on the right-hand side you divide by negative 1, it just changes the signs of each of those terms. So negative v plus z plus 2. Final answer. Okay, so I'll do this twice. So we ended up with a negative c at step 2 and step 3, and we had to deal with that eventually, right? So I don't like negative numbers. So here's a different approach that doesn't involve negative numbers. So I'm going to look at the original problem here, and I can see that I have a negative c in there, and already I know, hey, I don't want negative numbers. So as an alternate first step, I'm going to add c to both sides of the equal sign. Let's try to add c more legibly. Yeah, so these c's cancel, z comes down, plus 2 comes down, v plus c on the other side. And then to get the c by itself, I'll have to subtract that v. And that means I'm going to have the c equals, start on the right-hand side. Okay, and then I'm going to go left to right. So I got z minus v plus 2. Final answer. Okay, the order that you write this doesn't matter. So you'll see a couple of things different between those two different answers. And the one I circled in blue ink, it's got c equals on the left-hand side, and the flowery circled one, it's the c is on the opposite side of the equal sign. That doesn't matter. The two sides are equal. They are the same. So it doesn't matter whether you have c on the left side or the right side. Also, inside the blue circle, the order of my variables is different. I have negative v plus z plus 2. But in the flower circle, I've got the z first, z minus v plus 2. So as long as each of those terms has the same sign attached to it, the v is negative in both cases, the z is positive, the 2 is positive. So those are equivalent. They mean exactly the same thing. I've written it differently. I wrote it differently. I wrote it in a different order. They mean the same thing. They're both correct. The one I circled in blue is actually the better, that follows math convention, which says we always put variables before constants. So the variables, the v and the z first, and the 2 comes afterwards. And if you have more than one variable, put them in alphabetical order. So the v comes earlier in the alphabet, so I put the minus v and then the plus z afterward. Okay, you're not going to get marked wrong for that in the assignment, but that is the math convention. Okay, let's do another example. I'm going to solve this one for c. Also, I'm going to have to do a little bit more work this time. Scroll that old work out of here. Okay, solve for c. So let's get rid of the a. The c comes down, the a is gone, minus y equals 3 minus a. I'm going to follow the convention I just said. It's nicer to write 3 minus a, but the convention will have us put negative a first and then plus 3 afterwards. You can do it either way. Get rid of that y. So the c comes down equals negative a. I'm going to do the variable in the middle right there, and then the plus 3 at the end, just following my math conventions that I just talked about. Okay, and we got so many examples here. It's actually the last one on this page. Again, solve for c. Let's get rid of the x first. So the c comes down, x's are gone. Plus 4 is still there, equals. So I'm going to put the x first and then the y just to follow my alphabetical order. It would be more simple to put y minus x, and that'd be fine, but I'm going to do the negative x first. And then, oh, no, don't add. No, don't add. Adding won't cancel anything. I need to do the opposite. So I need to subtract 4, subtract 4. 4's cancel. C equals negative x plus y minus 4. Let's try rainbows. Let's see if I can get a better circle this time. Yay! Look at that. All right. Okay. Last example. This one's a little bit more involved, so we've got a set of parentheses in there to do some grouping. Okay, so let's take care of that group first. So we know that there's an invisible 1 on the parentheses, so minus, and then the parentheses, y plus 4. Okay, that means -1 multiplied by that group, right? So C will come down plus A. Neither of those are touching the parentheses, so the C and the A do not change. And then I'm going to take this -1 and multiply it onto the y and then onto the 4. So let's follow the green arrow first. That'll be -1y. You can put the 1 if you want. I'm just going to do -y. And then the blue arrow, -1 times 4, that's going to be -4. Other side of the equal sign equals 3. Okay, supposed to be solving for C. I didn't highlight it this time yet. There's what we're trying to isolate. Okay, let's get rid of this 4. So here we have some like terms. The C is going to come down, A comes down, minus Y comes down. Come on, computer. Let's make that look like an A. Thank you. Okay, equals like terms. So 3 and 4, those are both numbers. I combine them. 3 plus 4 is 7. Now let's get rid of the Y. Get some more space. C plus A equals, I'm going to put the Y first, Y plus 7. And then last step, subtract A, line that off. I wrote really big, so I need more space. Okay, these cancel. C comes down, equal sign comes down. I'm going to put the A at the beginning, so in alphabetical order. So -A plus Y plus 7. If you had not changed up the order, that'd be totally fine. If, let's say, we just left it as 7 at the beginning of our number sentence, 7 plus Y minus A, since I had a 7 written there first, and then add the, oh my gosh, it won't let me write. 7, 7, there it is. Okay, the first thing we did in red was add Y, and then the next step was to subtract A. Make this look more like a C that's legible. Also correct. There's several different options. You could write those same terms in a different order. It doesn't matter. You're not going to mark wrong for having a different order. But you can see between these two different answers, C is the same, like an equal sign, and then there's a positive 7 here. This one has a positive 7. It's got the plus sign. The next term, positive Y. This one's got a plus Y. And then the last one is negative A. This one we'd probably read as minus A, but the negative sign would goes with the A. Okay, they both mean the exact same thing. Oh no! Oh, sheesh. I erased way more than I wanted to. I'm just trying to make that little tail on the A not quite so big. Okay, good luck.